So hello everyone, welcome back to my channel. This is the first video of our FAANG DSA series. In this series, we'll be covering important FAANG level DSA questions, and in this video, we'll be covering the two-sum DSA question, which is a LeetCode problem. So let's get started. So let's first try to understand what does the question tries to say. It says that you'll be given an array of integer nums and an integer target, an array nums and a target. Return indices of numbers such that they add up to the target. So basically, you'll be given a nums array like this, and you'll have to return those two values in the nums array that sum up to this target. So in this example, we have 0 and 1 indices that add up to 9. As you can see, 2 plus 7 equals 9. Further, it has 3, 2, 4. In the second example, the nums array has 3, 2, 4 as values, and it wants a target 6. Therefore, the output would be, which is the index of 2 and 4. One important assumption that has been given, you may assume that each input would have exactly one solution, and you may not the same element twice. It means that the element at the same index, I can't use twice. Once I have used it, you can return the answer in any order. So it doesn't matter whether you return it as 1, 0 or 0, 1. The answer would be correct. So let's try to understand some brute force way of doing it. So let's take this example. Over here, I am having a nums array and a target value. I need to find two indices that add up to 9. Let's devise some brute force way of doing it. What I can do, I can create a nested for loop, the starting index till the ending index. In the second for loop, traversal will begin from I plus 1 and end at last index, inside which you have the if condition to check whether we have found our target. So this is exactly what I have implemented, the brute force method. I'll be getting this nums and target. I have used two loops. I'll be receiving this as my two parameters, nums and target. In my two sum function over here, the first for loop would run from 0th index, one less than the length of the nums array. And the second loop would start from I plus 1 and would continue till nums.length minus 1. This is the condition to check if nums of I plus nums of j equals to our target. If this condition is true, then we have got our answer, and I'll be returning it as my answer. So you can see there's a complementary return statement, but this won't be executed as in the question itself. It has been given that there will be exactly one solution. So this condition would execute every time. Let's run this. This is what I have got. Index 0, 2. Index 0, index 2. But it is not the most efficient solution. Time complexity is big of n square, and the space complexity is big of 1. Now make it time complexity efficient. So then I'll come up with another optimized approach. Instead of this brute force, I'll try to use a HashMap in order to make it time complexity efficient. So let's implement our HashMap idea. Over here, I am having an input array and a target variable. Both of them I am receiving as an argument to my function. And this is my HashMap, which I'll be using as an auxiliary space to make the solution time complexity optimal. Let's see how will I be doing that. I'll use a single for loop and start traversing from the first element. First, I'll be encountering 2. So this is my current element. This is where the complement variable comes into picture. It will be containing the value target minus nums of I, which is basically my current element. Better I'll be writing it as current. So currently 2 is my current element and 9 is my target. 9 minus 2, answer will be 7. I'll be checking in my hash map whether there is a value 7 already present. It does not contain the value 7. After that, I'll be storing the current element inside my hash map along with its index, just like this, value to index 0. Now jumping on to the next element, 11 is my current element and 9 is my target. 9 minus 11 equals minus 2. Is there minus 2 in my hash map? No. Still we didn't reach our answer. I'll be storing the current element and the index, and then I'll move on to the next element, which is 7. Again, this complement variables comes into picture. 9 minus 7 equals 2. Is there 2 in my hash map? Yes, there is a 2 in my hash map. It means we have reached our answer. So what value will I be returning? I'll be returning the index of my current element, which is 2, along with the index of the element that I have found in my hash map, which is the complement of our current element. So our answer that I'll be returning is 0, 2. So I'll be returning 0, 2. This is how our hash map logic would work. So let's now implement this logic in the form of code. First of all, I'll be starting by creating a hash map, which is the whole crux of our logic and which is our auxiliary state. I'll be starting off by making a for loop for the traversal of my nums array. I'll be running it from the index 0 till the 1 less than the length of my nums array. Here is my complement variable, which I'll be using to calculate the value target minus nums of I, which is my current element. Now, let's check if the complement is inside my map or not, hash map or not. For this, I'll I'll be checking in a if statement. If this condition is true, meaning if the complement is inside the map, I'll be returning the index of the complement along with my current index. This will be my answer. Further, if this condition is not satisfied, I'll be putting my current value in the map, in the hash map, along with the text. And in the end, in case of no solution, an empty array would be returned. But it won't get used as it is given in our question that you may assume that each input would have exactly one solution. There would always be a solution. So let's talk about the time complexity and the space complexity. Since we are traversing this array only once, so the time complexity would be big O of n. And talking about the space complexity, since we are using an auxiliary space hash map, so the space complexity would be big O of n. So let's run our code. So it has passed all the test cases and it is highly time complexity optimal. So this was all about the two-sum problem. If you have any doubts, you can put it down in the comment section. I'll try to answer that. So thanks for watching the video. See you in the next video.